Okay, so now the last one I'm going to talk about is Amundsen's law. Okay, and Amundsen's law says that pressure is directly proportional to temperature. Or in other words, P1 over T1 is equal to P2 over T2. So this graph, so somehow I copied and pasted two graphs onto my Charles law. So that's what happened here. Okay. So, but it's similar to the other laws that we described, and it can be related to the fact that as these molecules change temperature, as they get hotter, they get more excited, okay? And so now this, of course, picture makes perfect sense because for a fixed volume, right, this is a piece of glass. So it's not going to expand or contract like the balloon does. So as these molecules get hotter and they're pushing against that glass, the pressure has to increase, okay? And I think I have a sample. I'm going to use Kelvin for this calculation. Okay, so this is a fun problem. Labels on aerosol cans caution against incineration because the cans may explode when their internal pressure exceeds 3 atmospheres, 3 times atmospheric pressure. At what temperature in C will an aerosol can burst if the internal pressure inside the can is 2.2 atmospheres at 25 degrees Celsius? Okay, so let's back up. Well, what are we asking? Okay, at what temperature will an aerosol can burst if the initial pressure inside, and I'm just going to right away call that P1, is 2.2 atmospheres, at 25C. So that means this T goes with this P. And I am going to turn that into Kelvin, but then I'm going to have to turn it back into Celsius to finish the problem. Okay, so 25 Celsius is 298 Kelvin, 25 plus 273. Okay, and now I'm going to say P2 equals 3.0 ATM, and I want to solve for T2. That's going to tell me at what temperature will this can burst, okay? And let's remind ourselves, Amundsen's law is P1 over T1 equals P2 over T2. So that's going to be, so I like to do the algebra first. I like to get the equations all arranged in the way that I want. So now I'm solving for T2, okay? So I'm going to multiply both sides by T2, okay? And that gives me T2 times P1 over T1 equals P2. And then now I'm going to multiply both sides by P1 over T1 to cancel these things. Let's see here. Excuse me. Let's back up for just 1 second. Okay. So I canceled the T2 and the T2, right? So now I've got T2 times P1 over T1 equals P2. So remember, I'm solving for T2. So now, yes, I'm going to multiply by T1 over P1, both sides. Okay? So that cancels my P and my T. And now I know T2 equals P2 times T1 over P1. And now my P2 is 3 atmospheres times my T1 is 298 Kelvin. And my P1 was 2.20 atmospheres. Okay, so when I do all of that, 3 times 298 divided by 2.2 equals, okay, so that's 406 Kelvin, but it's asking me for the answer in Celsius. So now I'm going to say minus 273. And that would be to the nearest 1 degree C, 133 degrees Celsius before that aerosol can will explode. Okay, moving on.